In Module 3, Section 6, we will continue to look at the problem-solving process. Specifically, we will look at problems with percents and mixtures. This is a review over the general strategy for problem solving. You've seen this before. The first step is to understand the problem, then we will translate the problem into an equation, solve the equation, and interpret the result. You want to make sure your answer is possible and that it makes sense. First, let's look at solving percent problems. A percent problem has three different parts: the amount, the percent, and the base. I'm going to go ahead and redefine base, or at least give us another word that will hopefully make it make a little more sense. The base is the whole, or the original amount. And so we have an amount. You can think of the amount as maybe the part or the fraction that we have. The base is the original, the whole that we started with. Now, in this equation where amount equals percent times base, it's possible for any of these three quantities to be unknown. Hopefully not at the same time, because that would involve a different problem-solving method. So let's look at the three possibilities below. When we do not know the amount, we would have a variable on the left side. When we don't know the base, we would have a variable on the right side. And when we don't know the percent, we would also have a variable on the right side in place of percent. So let's look at an example. 91 is 2% of what number? Now this can be solved through a direct translation, meaning that we go from left to right and we write the key words as mathematical operations that we solve. So we start with 91. 91 is, remember, is means equals or equal to 2%. We'll deal with this percent sign in just a minute. Of, anytime you see of, that represents multiplication. What number? X. So this would match the example from before where we don't know the base or we don't know the original amount. Now we can't solve a problem where we actually have a percent sign in the problem. We need to rewrite any percents as decimals. So hopefully you remember from Module 1 that to write a percent as a decimal, we would divide by 100 or move the decimal to the decimal place 2 times to the left. And so dividing by 100, that gives us 0.02 times x. To solve for x, we divide both sides by 0.02. When we do, the 0.02's cancel on the right-hand side, and we have x equals, to find the value we're looking for, we take 91 and divide by 0.02. And that will give us 4,550. So before we move on, let's see if that number could make sense. 91 is 2% of what number? Well, if 91 is 2% of the number, then the number should be much larger than 91. And in this case, it is. And so hopefully we can go through that. We've done the math correctly. And the answer, even if we can't guess what the answer would be, it somewhat makes sense. Let's try another example. 105 is what percent of 70? Again, this is a direct translation. So 105 is means equals what percent x of times 70. Now, one piece of the problem we haven't dealt with yet is percent. We're going to save that for the end once we have an x value. So again, we want to solve for x, so we divide both sides by 70. The 70's cancel on the right side. We have x equals 105 divided by 70, which will give us 1.5. Now, like I mentioned at the beginning, we haven't dealt with the fact that we want a percent as an answer. Right now, we have a decimal. That's what 1.5 represents. To go from a decimal to a percent, remember we multiply by 100. So we take 1.5 times 100, and that will give us 150%. Now let's try an example where we will still be using percentage, but we will be using it in terms of a word problem. That will not be exactly a direct translation. Icy River increased the price of a $1.70 cola by 25%. Find the increase in price and the new price. So when we have markup problems or discount problems, this is the way that we can go about solving. We want to find first the increase in price. So the amount will equal the percent times the base. Well, what we are looking for, remember the base is the original. We know the original price. That's $1.70. The percent, the markup was 25% or 0.25. The amount, that's going to be the increase. We don't know that. So to find the increase, we'll just call it X. We'll multiply 25%, 0.25, and 1.70. And that will give us 0.425. So that's going to be the increase in price. To find the new price, we take the original, so the new will equal original plus increase. So the new will equal $1.70 plus 0.425. Well, if we add those together, 0.425 plus $1.70 gives us 2.125. Now remember, we're talking about money, so it would make the most sense to round to the cents place. So let's take this and round it to 2.13. Again, we use the logic test. The end price is higher than the original price. And that makes sense because we wanted to increase the price by a certain amount. Now let's try to find the original price of a pair of shoes if the sale price is $91 after a 30% discount. Well, if we try to use the same equation that we used in the last example, amount equals percent times base, where base is the original, we'll have to be somewhat creative in solving the problem. What we are given is actually the amount. We're given the sale price, and the sale price would fit on the left-hand side where we see amount. So $91. The percent will be the percent remaining after we took a discount. So the percent here will be 100% minus the discount, or minus 30. And the base, which is the original price, is unknown. That's what we're trying to find. So we have 91 equals 100 minus 30 is 70. And we need to write that percent as a decimal. So 0.70 times X. So we divide both sides by 0.70. The 0.70's cancel on the right-hand side. We're left with X equals, to determine the original price, we take 91 and divide it by 0.70. And that gives us $130. Again, we use the logic test at least to make sure we were going the right direction. If the sale price was 91, the original price should have been higher, and our answer was definitely higher than $91. There are other ways to work this problem, and your instructor may show you a different way, especially if this seems confusing. But using the amount equals percent times base formula, this is exactly how we would find the original price. This example will be very similar to the last example in the fact that we're trying to find the original number of employees. So let's read the example. A company recently downsized its number of employees by 25%. There are still 90 employees. How many employees were there prior to the layoffs? So let's start with the same formula. Amount equals percent times base. Remember, the base is the original, the amount is the new. So here, the new would be the 90 employees, the employees that are still left. So 90 equals, and we're not talking about 25% of the employees. We're talking about the percent of employees that were left after downside. So if we started with 100% of the employees and we took away 25%, that would be the percent that we now have that would equal to the 90 employees. In the base, the original number of employees, that's what we are trying to find. So we go further. 90 equals 100% minus 25% is 75%. And if we write 75% as a decimal, we have 0.75. Then we still have times x. So to solve for x, we divide both sides by 75. 0.75. The 0.75s cancel on the right-hand side, and we're left with x equals, now to find the original number of employees, we take 90 divided by 0.75, and that gives us 120. Again, if there were layoffs or if the company downsized, then there should have been more employees originally than 90. And our number at least has gone in the right direction. And we can see if we follow the steps, that's exactly how many employees there were prior to the layoffs. Let's try an example where we're looking at increase and decrease problems of the area of a shape. So by decreasing each dimension by 3 units, the area of a rectangle decreased from 60 square feet to 18 square feet. We want to find the percent decrease in area. Now this equation we're going to set up a little bit differently. Anytime we talk about percent increase or decrease of a shape, this is the formula you are going to use. The absolute value of the original area minus new area, all divided by the original area. So as we go through the problem, 60 square feet will be the original area. 18 square feet would be the new area. Let's take those two values and plug them into the problem. One thing I need to mention as well, let's multiply that result by 100 to change the decimal to a percent. So plugging in 60 in place of the original, 18 in place of the new. Now inside the absolute value bars in the numerator, we take 60 minus 18. That would be 42. So the absolute value of 42 over 60 times 100. The absolute value of 42 is just 42. So we put this in the calculator. We start with the division. 42 divided by 60. That would be 0.7. We multiply 0.7 times 100. That will equal 70. We want this to be a percent. That's why we multiply by 100. So the percent decrease in area is 70%. This formula will work for both decrease problems when we talk about the area or increase problems. The next example deals with mixture problems. It's one of possibly 3 different mixture problems you will see. There's a coffee problem, there's an acid problem, there is a lotion problem. You could also see this problem worked out with different ground beef, where the percentages of fat are a little bit different. So I'll show you the generic way to work every problem, and then we will work this particular example. A coffee company wants a new flavor of Cajun coffee. How many pounds of coffee worth $8 a pound should be added to 30 pounds of coffee worth $5 a pound to get a mixture worth $6 a pound? And so the basic formula for every mixture problem looks like this. Amount times rate plus amount times rate equals amount plus amount times rate. Now, on the different examples you will see, the rate could be a percent, it could be a cost. Those should be the only types of rates you will see. And there are other rates that are out there, but on these problems you will see percentages or cost per pound, per ounce, something like that. So let's go through the problem, and I'm going to circle the amounts in red and circle the rates in green. So the first amount is actually unknown. How many pounds? So the first amount is a variable. It's an unknown quantity. It says that is worth $8 a pound. Should be added to 30 pounds worth $5 a pound to get a mixture worth $6 a pound. Let's go ahead and circle the word mixture as well, because that's important for the last amount. So the first amount is how many pounds. It's going to be an X. So X times the rate circled in green is $8 a pound, or 8, plus the second amount is 30 pounds, 30, times $5 a pound, so times 5, equals, the next word circled in red was mixture. We take the first amount, X, the second amount, 30, and we add those two numbers together. So X plus 30, that's my third amount, times its rate, which was $6 a pound. We now have an equation that just needs to be solved. So we have X times 8, or 8X, plus 30 times 5, 150, equals, on the right side of the equation, we distribute the 6. 6 times X, 6X, plus 6 times 30 is 180. We continue to solve for X, so we move all of our X's to the left side. We subtract 6X from each side of the equation. On the right side, the opposite 6X's cancel. On the left side, 8X minus 6X is 2X. Everything else remains the same. Okay, let's carry this a little higher so we have enough room to work it out. So 2X plus 150 equals 180. Now let's subtract 150 from each side. The opposite 150s cancel. And we have 2X equals 30. So we divide both sides by 2. And X equals 15. So the number of pounds of coffee worth $8 a pound would be 15 pounds.